welcome back to Chapter 10, Classes and Object-Oriented Programming, and this is Part 2. We will speak about classes and how we can instantiate these classes and create our objects, as I promised in the previous session. Okay, so in this part, we will just address quickly, actually, a few slides about classes and working with instances, how we create a class and what actually is meant by a class in Python, and how we can instantiate it or create an instance of it, and what does it mean by this instance and the relationship between an instance and a class. Okay, class in a basic sense is a skeleton that combines your data as an attribute of an object, okay, and the methods operate on this data. So it's a skeleton or template, you can call it. Sometimes people refer to it by blueprint. It's just like a blueprint of a house. Or maybe you can take an example of a cookie cutter also, it could be. So it's just a skeleton. It's not an object by itself. No. So you have to differentiate. The idea of a class and object is actually, or the difference, or the main idea, or the main difference between class and object is we have a skeleton or a template where we can create an object out of. Think about the cookie cutter. The cookie cutter itself is not a cookie, but we can create a cookie using it, right? So this is exactly it. So a cookie is, a cookie cutter is a class, or can be an example of a class. And the outcome that it produces is an instance or an object. Also, the blueprint of a house. We can use this blueprint to create or to actually build different houses, yet the blueprint itself is not a house. So the class is the skeleton or the template where we can instantiate or create an object. So creating the object is referred to technically or in the programming sense by instantiating. So we instantiate what? An instance. So this instance is exactly an object created from the class. So we create a definition. The class is exactly the definition, the skeleton, okay? Then we can instantiate this class. All right, so instantiate it how many times? As many as you like, or as many as your problem or your program dictates, okay? So look at this. This is a blueprint of a house, which is a class where we can use it for building some houses. They will have an identical view based on the blueprint. We can customize a few things, but still, well, the areas will remain the same. The maybe internal planning or structure should be the same based on the blueprint. Yet you can a little bit modify and customize based on your own view of the object that you want to create, and which is a house in this case. And this is another example about the cookie cutter. It's a very actually good example of class and object. So if we think of this cookie cutter as a class, then these cookies made by the cutter can be the objects. So this one itself is not an object, it's just a class that can create, or we can instantiate or create objects out of or using it, okay? Now, if we want to give a real example, a real life example, there are so many. Earlier, or the previous session, I said about a student. Well, we may think about a student who's studying at the university, so we can call it university student. Or maybe we can also think about a student who's high school student, okay? What's the difference? Well, simply, one of them has a higher level than the other, so a little bit of the attribute, but both of them have names. Both of them have their own private data. They may match with the private data, I mean, as the type of the private data or the data attributes. In some cases, they may mismatch in other. So think about an insect or insect as a class. So we have certain characteristics or attributes for insects, all of them as one category. So think about two types of insects, maybe housefly and a mosquito. So these two are objects of insect. They carry the same attributes. Maybe you can customize some other attributes for the housefly and for the mosquito. Okay, so this is the idea. Or you can use these objects for, I'm not quite sure what we can use them for, but maybe for some study you need to investigate things related to housefly or things related to mosquito. Depends on the type of the problem that you are solving or the program that you are creating. So we can use this template or class insect, and then we can instantiate. And this is not necessarily, or not necessarily restricted to housefly and mosquito. You can list down as many as your problem requires. Okay. How can we create this class definition, or how can we create the class? So we need to define a class. And in order for us to create the definition of class, we use the keyword class, and it is lowercase all. And then we give a class name. And by convention, class name has a capital initial. So the first letter in the class name that you're going to give, this is a user defined name. So it applies the name here, applies same rules apply to the naming of a variable, but here is a class. So in this case, we have to pay attention to the name. It should be a valid name, but capitalize the initial. This is a convention. If you don't do so, your program will work, but it wouldn't be actually conventionally acceptable. Okay. And then we have the colon that allows us to have a scope, which is a definition similar to methods. Instead of having def and method name, then the parameter list, that we have a class as a keyword, class name, and then a scope. Okay, then we need to have set of statements that define the data, okay, and the methods. So the data, the attributes that the class has, and the methods applied or operating on the data or the attributes. Okay. So once we create the header line, we can call this one a header line. Then we go to the scope where we have the private data or the attributes, and then the methods. Okay. One thing I have to define or I have to clearly mention is, if you remember from Java, we studied Java before in algorithm and programming. And for those who do not know Java, think about a constructor. A method, a special method that starts or initiates the class when we instantiate an object from this class. So we have the constructor in Java. The first thing to be called when a class is instantiated. In Python, we have something we call initializer. It's very similar to the constructor in Java. You can write a class without the initializer, but it's not recommended, at least in my opinion. You should stick to the way where you provide initializer in your class, and then based on this initializer, you can manipulate other methods, especially when you just start up or assign values to the attributes, the private attributes. Okay. One more thing I have to say, when we instantiate the class, we get this reference, and this reference is needed by the definition of the class. And this is what we refer to usually by self. You can give it another name, but this is the conventional name. So if you keep this name while coding, it will be more convenient. So self will be the reference that is provided as an argument or a parameter, you can call it in this case, to all methods available in the class. And it actually tells the methods in the class to operate in what object exactly. Okay, so which specific object you want me to operate on? Okay, this object. So I know which object. And now when I give an example, a real example, you will see, you will understand. Okay, so I spoke about the initializer. One thing I didn't say about the initializer, it has its own distinctive way of definition. We have the double underscore. These are double underscores. Okay, and here double underscores. The first one here, it means it's private, and we will see how we create private, but this one is just a special case where we keep it the way it is. We also have str, similar to this. We have some methods like that. This is the way they are created. We have to stick to their format, okay? And then we provide self. So this is a method, okay? In this case, it's a method. The only difference that we didn't actually see before as a method is having the underscores here. Think of it as a format in this case, and private definition in this case here. All right, so we have a parameter. So this is an argument. So we will pass an argument to self. So we have self as a parameter, okay? And this is a normal method that we, like the methods that we usually have in our procedural oriented. The rest is just a standard initializer. We have to keep its format the way it is in order for us to use it. Okay, think about creating a class to simulate a toss of a coin. If you toss a coin, you may get heads or tails. So if we think about a class to create that simulation for us, we need to have random. Why? Because the tossing process itself is a random, is a completely random process. So we may get heads or tails, and in that case we can call or we can import, not call actually, we can import the random module, and then we can use a random integer, let's say 2 integers only, 0 or 1 for example. 0 that simulates maybe heads, 1 simulates tails, and in that case we can make our toss. So now we create the class. The first thing is keyword class, and then we need to provide the class name. As we said earlier, by convention, capitalize the initial, okay? Then we create the scope. Now we can create all our methods inside the class, and also define our private data or our attributes. Usually the attributes are set to private, and this is what I was referring to by double scores at the beginning. We can also set this one to private. I'll explain about it in next session, not in this session. So in this case, the first to meet by convention, by the way, also, it's not the format, but by convention, the first to code or to write in a class is the initializer. So we write the definition same like other methods that we learn. We just need to provide the format itself, double scores, double underscores, init, double underscores, then the self. Self is a compulsory in this case because it determines the reference of our objects that we are going to operate on. Define your data. So when you want to define data, data belongs to which object? Self. So the object that I just created, or I instantiate the class, created from the class, okay? Instantiate the class to get it. What kind of attributes do we have while tossing a coin? The side. Which side? So now we have only one attribute. That's the side up, the one that we see when we toss a coin. Okay, so this side up could be heads or tails. You can initialize it to heads or you can initialize it to tails. It's up to you. Okay, you can assume that it is now on heads or now on tails. So it depends on the way you define it. Then you need to simulate the toss itself. So you need to create a method for it. You can give it any name, or you can just call it toss, and you have to pass also the argument and create the parameter self, so that you can access to the side up and manipulate it. Now we can use a random process to simulate the toss. If it is 0, we can assign it heads. If it is 1, otherwise, that means else, it would be tails. And in that case, what we are going to have is a simulation of tossing of a coin. Okay, now we toss the coin. How can we get the result? So we need to create another method to get the side up. And I think you guys still remember from previous programming you studied about accessors and mutators. We will explain about them in another session. However, this is the idea. We need to get the side up. So in order for us to do so, we create a method. And also we need to provide self and then return the side up. And how can we return the side up? We use self to access the side up and return it. Okay, this is our class. So I have this class. How can I instantiate an object out of this class or from this class? I use the class name. Okay, I create my object name and I use a class name with parentheses. Since we don't have anything to be passed here as an argument, so this one is by default has no argument. So coin has no argument, it's just self, and that's an automatic reference. You can change the name self, and my recommendation is not to, just keep it the way it is. Once you create this instance, the reference will be assigned to coin and it will be passed to self. And this self is passed to all other methods available in this class. So if you want to use any of these methods now, you use the object name dot method name. Okay, my coin dot get side up, and the method here is not requesting any argument. Self is default, you don't pass any. Self is default, okay? So you don't pass it, it's passed by default. So if you call get side up, you will just get the default side up initially, okay, whatever available. Then maybe you can make some toss, so you can call the toss function a method, and then you can get the side up. Every time you will get maybe heads or tails, it depends, this is random. So this is the way we create class and instantiate it. Okay, now look, let's have a closer look. This closer look here, we speak about the coin. This is an object, and once it is created here, like here, once we instantiate an object out of it, what happens? A reference will be automatically created. We don't do it, it's automatically created and assigned to self, and then we can have all the access we need inside the methods of the class. Okay, so I explained about how we instantiate or create actually a class. So we use our object name. Use the name that you like, the name that fits you. So here, for example, my coin, you can use maybe coin or coin1, whatever. Okay, and then use the class name with the parentheses. Since we don't have any argument to be sent next to, we can have argument list, we can have a comma and then some other arguments. Here we don't have. This is the simplest way of creating a class, so it will be just by default with no any argument. And once this object is created, the reference of this object will be passed to self, like here, and then the methods will operate on this object particularly. Okay, if you want to use a method, class name, object name dot method name, and that's how you access to it. If there is an argument to be sent, now we don't have, because we just have self and this is automatic. So if you have an argument list, that means if you have some commas here and some other arguments, you must pass them. We will see them later on, not now, okay? And this is exactly how you create a class and then how you instantiate an object out of it. Well, I'm not going to explain further. That's enough for this session. We will have some other examples in next session, and we will have, like you can say, dive deeper in creating classes and how we manipulate their objects. Until then, have a good time. Goodbye.